हेलो एवरीवन, हाउ आर यू? कैसे हैं आप लोग? राइट, इट्स टाइम टू डिस्कस द कम्युनिकेशन फॉर गेट पॉइंट ऑफ व्यू, दैट इज फॉर द गेट EC, और आई एम डिस्कसिंग द टॉपिक दैट इज कॉल्ड एरर करेक्शन एंड डिटेक्शन, राइट? और वी कैन से दैट एरर डिटेक्शन एंड करेक्शन, राइट? नाउ yes, Jagdish, good evening. Naman, Vicky, right? Lavanya, good evening, dear. That is the brief idea about me. My name is Chandan Jha, right? I'm taking communication network, conducted more than 200 motivational session. Apart from the motivational session, I'm teaching the classes of the digital electronics control system, signal system, communication, and the microprocessor, right? Now, the total number of days left for the gate is 40 days, right? Just plan yourself according to the 40 days, right? Now we are going to discuss the topic, the error detection and error correction, right? That is in the digital communication. So in the digital communication, that is the one topic that is called the information theory, right? Information theory. In the information, there will be the error correction and error detection code. So first we are going to discuss how the error will be detected. After that, we will discuss about how the error will be corrected, right? Yes, सूरज कुमार से DMRC के लिए भी है क्या कुछ? दो DMRC का सिलेबस मैंने नहीं देखा है. डेफिनेटली अगर DMRC का एग्जाम में कुछ रहेगा तो डेफिनेटली विल डू समथिंग फॉर यू, राइट? So now the error detection and error correction. Just remember, there will be the few points, right? There will be two method, right? For the detection, for the error detection and error correction or coding technique. The one is the block code and another one is the convolution code. Generally we will discuss about the block code. हम block code के बारे में भी discussion करेंगे और थोड़े डिटेल में जाके हम discussion करेंगे, right? Now just remember one thing in the block code. Any block code is represented by like this, n by k, right? N comma k, when n represent the total code length, or we can say that code length, and k will represent the data length. So if we want to increase the data, if we want to find out the error for a particular instant, then along with the data there will be the one thing that is called what? That is called the parity bit. Parity bit it added to improve the, or we can say that to find out the where the error will be taken place in the which position. किस position के अंदर error आया है, to find out that we have to add some parity bit. So sir, what is the parity bit? Let k is the data bit and code length is n, then there will be n minus k equal to m I am using, and it is the number of parity bit. Parity bit should be added. Number of parity bits should be added. Now, right, Anil Kumar, Jai Shri Ram. Now, for the number for parity bits, right now, just remember one thing. There will be the few definition you should remember about that. After that, we are going to discuss, or we are going to solve some question related to what error detection and error correction. So first, what is n? N is nothing, it is just a code length. What is d? D is nothing. K is nothing, it is just a data length. And the one thing more, that is m. M is nothing, it is just a number of parity bit. Now, if just example take 6,3 code. If there will be the 6,3 code, then we can say that the total number of code length of the signal is what? 6. And out of 6, there will be the only 3 bit is a data bit. So to make the 6 bit, we have to add 3 extra bit, that is called the parity bit, right? Or kya benefit hai? What is the basically benefit of the parity bit? We'll look into the next, right? Sir, please slow study. Okay, Jagdish. So there will be the what? There will be the 1 6, that is called what? The code length, and the 3 is nothing, it is just a data length. Now we can say that it is a data length. Now how many parity bit are added? So find out the parity bits. 6 minus 3, that is the 3. So we should require what? We have to add 3 parity bit along with the 3 data bit. Actually है तो हमारे पास data ही bit, और उस डेटा बिट को क्या करना है? टोटल कोड 6 लेंथ बनाने के लिए हमको 3 पैरिटी बिट ऐड करना पड़ेगा टू फाइंड आउट द वेदर द एरर इज प्रेजेंट इन द सिस्टम, राइट? नाउ सो आई एम राइटिंग n minus k parity bits are added. Take the example, I have taken the example 6,3 bit. So in the 6,3 bit, there will be the 3 bits of the data, and 3 bit I am writing parity, that is P1, P2 and P3, right? Now, there will be the 2 types. We can split the code into 2 types, right? One is called what? One is called the systematic code. Another one is the called non-systematic code. Yes, Suraj is asking one question. Sir, parity bit is for safe transfer for the information without any loss, right? Yes, Suraj. For the parity bit, we have to add to find out or to transmit the signal in the safe mode, right? Now, so I'm writing. Now there will be the code is split into 2 parts. The one is the systematic code, another one is the called non-systematic code. Now what is the systematic code? If data is represented or data written separately and the parity bit is written after that data, then that type of code is called systematic code. So we know that in this code there will be the 3 data bit and 3 parity bit. 3 data bit है, 3 parity bit है. So अगर मैं data को पहले लिखता हूं और बाद में parity bit के सारे parity को मैं बाद में लिखता हूं, then that code is called what? Systematic code. तभी हम उस code को बोलेंगे systematic code. और अगर हम data parity को mixed कर दें, if we are mixing the data and parity, first I am writing data, after that 2 parity, then after data, then parity, and then there will be the data. Then there will be the mix of the parity bit and the data bit. That's why it is called what? It is called non-systematic code. Right? So अभी हमने देखा what? There will be the 2 type of code. First, yes, Krishna, good evening dear. We have seen there is the 2 types of code. The one is what? The systematic code. Another one is the non-systematic code. In the systematic code, we have to form, in the systematic code, we have to use what? We have to write every data before the parity. After that, the parity will be read, or if there will be the mix up of the parity and data bit, that is called the non-systematic code. Now in the codes, there will be, yes, there will be the one question Vasudha is asking, when we have radar classes. Actually Vasudha, there will be the some, you know what, that is the scheduled plan, and definitely we'll schedule for the radar classes also, right? There will be the schedule for the radar class also, so don't worry about that. Anitha, can you explain in the English, sir? Actually Anitha, I'm explaining in English also. I'm just using the few words in the Hindi, right? Now, these things are work on the what? Modulo 2 addition, right? One thing was generally in the communication, modulo addition is given. Modulo addition. So what do you mean by modulo addition? Just remember one thing. For modulo 2 addition, if we given modulo 2 addition, then in the modulo 2 addition, what happened? There will be the only 2 bits, right? Either 0 or 1. So in the modulo, there will be the 2 bits. So I am writing, there will be the only 2 bits, 0 and 1, 0 and 1. And if we are performing a modulo 2 addition between it, 0 modulo 2 addition with 0, the result will be 0. 0 modulo 2 addition with 1, the result will be 1. The modulo 2 addition with 1 and 0, the result will be 1. Modulo 2 addition with 1 and 1, the result will be 0. So it is nothing, it is just a XORing. It is nothing, it is just the same as a XORing operation. It is just same as a XORing operation. Now what happened in the modulo 3 addition? Modulo 3 addition. If in the problem the modulo 3 addition is given. So in the modulo 3 addition, there will be the 3 signal, 3 bits, right? Right, Kundan Singh, sir, I am late today. No, you are not late, you are in right time, right? So don't worry. Soumya, good evening, sir. Good evening, dear. So my dear friend, if you want to find out the modulo 3 addition, there will be the 3 bits. What? 0, 1 and 2. And there will be 0, 1 and 2. So 0 modulo 2, 0, 1 and 2. Now 1 modulo with the 0, the answer will be 1. Modulo 1 addition with the modulo with 3, the answer will be 1, the answer will be 2. And 1 modulo with 3, the answer will be 0. So again there will be the 2, 0 and 1. It is called modulo 2 addition, modulo 3 addition, right? Sir, explain with example. What example you want? We'll explain everything with the example, so don't worry Ayush. सब कुछ हम डिस्कशन करेंगे in very you know what, in very detailed manner in this class, right? So don't worry. Right now, so modulo 2 addition is nothing, it is just a what? XORing. So you all are aware 0 XOR 0 equal to 0, 0 XOR 1 equal to 1, 1 XOR 0 equal to 1 and 1 XOR 1 equal to 0, right? Okay, just give me the answer. Everybody just respond me. XOR follow the associative law or no? Just give me the answer. XOR follows the associative law or no? or not? Just give me the answer. Everybody just respond it. Everybody just respond me. Yes, yes. Okay. Modulo 3 addition again. Okay. In the modulo 3 addition, nothing. There will be the 0, 1, 2, 3. I'm writing 4. And of the addition, there will be the 4, right? So, if you want to perform a modulo 3 addition, then what type of the modulo 3 addition? What is the basically exactly the modulo 3 addition? If the result, if you are adding 0 with 0, right, that is the modulo 3, then result will be 0. If you are adding with the 0 with 1, then you are 1 with the 0, the result will be 1. When you will get the result 2, that will be 2. But there will be the only 0, 1, 2 in the answer. So after that, whenever you add this signal and it will become 3, then the 3 again will become 0. And after that, will you add it, then it will become 4, 4 again will become what? 1. So it is called what? Modulo 3 addition. So 1 addition with 2, the answer will be 3. At the place of 3, we have to write 0. So I am writing 0, right? So 2 addition with 0, the 2 addition with 1, the result will be 3. So at the place of 3, I am writing 0. Now 2 addition with 2, the result will be 4. At the place of 4, I am writing 1, right? So in the today class, will you cover the modulation technique AM, FM, PM? No, this class is not basically for AM, PM, FM. This class is for the error detection and correction. Yes, in the YouTube you are very good. Krishna is giving the no. Okay, just give me the answer. Just give me the answer. XNOR, again I am asking, XNOR will follow the associative law or not? Just give me the answer for this, right? XNOR will follow the associative law or not? Right? And if anybody, yes, Ayush is giving the answer no. Jagdish is giving the answer no. Umesh is giving the answer no. Jagdish is also giving the answer no. XOR follows the associative law, yes. XOR follows the associative law, and XNOR also follows the associative law. Associative law. XNOR भी दोस्त associative law follow करता है. And one thing remember always, A XNOR B XNOR C, if you want to find out, right? So no time explaining this, but in the mind, just keep it in mind. XNOR follow, XOR and XNOR both follow the associative law, right? So Smriti, Anu, who is giving the answer no, actually everybody is giving the answer no. That is the answer for this. The XNOR follows the associative law, right? That's why in the every place we are writing, right, A XNOR B. For the even and odd, we are splitting, so I am not explaining it. You all are aware about that, right? So just remember, XNOR follow the associative law. Right now, for this, that is the error correction and error detection code. Now just remember, 0 XOR 0, 0, 0 XOR 1. If they are different, then the answer will be 1. If it is the same bit, then the answer will be 0. So that's why I'm writing 0. Now, for the modulo 2 addition, if there is the 2 codes, C1 and C2, there will be the 2 codes, right? C1 and C2, 2 codes. So I'm writing, yes, there will be the one question, universal gates does not follow. So yes, universal gate does not follow the associative law, but XNOR is not a universal law. Universal law is only the NAND gate, NOR gate, and inhibitor. By the inhibitor or inhibition, we can form the what? Every logic. So inhibitor, inhibition, XOR and NAND and NOR. These things are called universal logic, right? Now, in the error correction, so if we are finding the modulo 2 addition between these 2 codes, then 1 XOR 1, that answer will be 0. 1 XOR 0, 1. 0 XOR 0, 0. 1 XOR 1, 0. 0 XOR 1, 1. 1 XOR 0, 1. So if the bit are different, the answer will be 1. If the bit are same, the answer will be 0. That is called modulo addition. So I am not performing the XORing. Actually, I am doing the what? I am doing the modulo 2 addition on it. Right now. Now, just remember few words, few things or few definition is always required to remember everything, right? What is that? The few things, everybody is responding for the XNOR associative law actually, right? Always remember, dear, XNOR follows associative law, right? Now, for the next one, there will be the two things we should always remember, right? What is generally in the question you will see there will be the linear code in mention, right? There will be the linear code in mention. So what is linear code? Which code is called the linear code? So linear code is a code when it is generated by the addition of the two codes. When any code is generated by the addition of two codes, then that code is called a linear code, right? So a code is said to be a linear code if code is generated by the addition of two codes. Then only that code is called what? That code is called linear code. Now there will be the one, so we all are aware about the linear code. What is linear code? If any code is generated by the addition of two codes, then that code is called a linear code, right? Second one, what about this? The second one is the Hamming weight. Second definition should remember about Hamming weight. What is Hamming weight, right? So for finding the Hamming weight, just remember one thing. Hamming weight indicate that if any code is written, and if you want to find out the Hamming weight for that code, then the total number of one present in that code is called Hamming weight. So if I'm writing the one code, just take the example C equal to 1010111. That is, I'm writing the code. And if I'm just giving you one question, find out the Hamming weight for this. So Hamming weight for this is nothing, just count the number of ones. Number one is 1, 2, 3, 4, 5. So we are saying Hamming weight is 5. Hamming weight is 5. Now there will be the another that is called Hamming distance. These words are frequently used for the error detection and error correction. These words are frequently used, right? Yes, Vishwa is asking, sir, when analog communication will covered? In the analog communication, I will cover only in the FM portion, FM or PM portion. We are not going to cover the AM and everything, right? Definitely we'll do in the next week, I think. I don't know actually the plan. If there will be the plan, definitely we'll do the FM and PM class, right? Right now, what is the Hamming distance? So Jagdish is asking, sir, today is my third semester physics distance n minus k plus 1. Yes. So if we want to find out the Hamming distance, the minimum, actually not, I'm writing minimum formula. What is the Hamming distance basically? So to find out what is the Hamming distance between the codes, just write out if I'm writing C1 and C2. So I'm just taking the example, there will be the two codes, C1 and C2. There will be the two codes, C1 and C2. I'm writing C1 1010111. That is the one code. And the another code that is called C2 is 011001. That is the second code. Now, if you want to find out the Hamming distance, then the Hamming distance is by at what position, at number of position, there the bit will be changed is called Hamming distance. Or we can say that Hamming distance indicate the number of location at which the two codes are different is called the Hamming distance. So if you want to find out the Hamming distance, so Hamming distance is nothing for this 1 same 1 0, that is the difference. So 1 same second and third. So at the 3 place the number of bits are changed. So at the 3 place the number of bits are changed, then we can say that the Hamming distance for this is 3. Hamming distance for this is 3. Vishnu, good evening dear. So Arun Shah, Hamming distance note 6, Hamming distance is basically for 3 for this code, right? Now, so you all are aware about the what? First, just remember few things, right? Few definition. The first, what is linear code? Okay, just first remember what is N, what is K. N is the total code length, where K is nothing, it is just about the total number or bit, or we can say that data length, right? So N is the code length, K is the data length. So two things we should remember. Second one, or what about the parity bits? N minus K is called the parity bit. That is the third one. Now, next movement. There will be the two types of code, systematic code and non-systematic code. A systematic code is a code in which the parity bit are separated from the data bit. If the parity bit, all the parity bits are written together along with the data bit, then it is called the systematic bit or systematic code. And if there is a mashup between the data code and the parity code, then it is called the non-systematic code. Now the third definition for the linear code, right? A linear code is a code when it is generated by the combination or addition of the two codes. If any code is generated by the addition of the two codes, then that code is called the linear code, right? Fourth one is the Hamming weight. If in the code, the total number of 1 present in the any code represent the Hamming weight. Third one, the Hamming distance. So if there is the two codes C1 and C2, then what place these two codes are differ is called Hamming weight. Hamming distance. So the Hamming distance for the particular that question is 3, right? So we have written. Now if I'm giving you one example, in a 6,3 codes, the parity equation are given, P1, P2 and P3 are given, right? Determine all the possible codes. We have to find out all the possible codes for this, right? If you want to find out all the possible codes for it, right? Upender, good evening, dost, right? Now if you want to find out, sir, I'm a student in Odisha. That's great. Jagdish. Now if you want to find out, determine the all possible code from this. So first of all, if there is the n equal to what? For this n equal to 6. And what about the k? K is number data bits. So k is 3 is given in the problem. So n equal to 6 and k equal to 3 is given in the problem right now. So number of parity bit m we should find out. That is nothing, it is just a n minus k. So it is nothing, it is 6 minus 3. So answer will be 3. So there will be the 3 data bit and 3 parity bits. Now by the 3 data bit, if there is the 3 data bit, so I'm writing the data bit D1, D2, D3. So there will be the data bit is nothing, it is just like, if I'm writing the data bit, by 3 we can form like 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, sorry, that will be 1, 0, 1, and it will be 1, 1, 0, and the last that will be 1, 1, 1. So there will be the 8 combination. And a person who are writing this code like this, 4 times 0, 4 times 1, 2 times 0, 2 times 1, 2 times 0, 2 times 1, 0, 1, 0, 1, 0, 1. So you are taking, or you are giving one mistake, right? Do not remember this type of code like, you know what, this type of a pattern. Why you are not right? Because if in the question they will ask about to make the table, or if you want to make the table of 128, then then you have to form all the tables. But if you are writing like this 0, 0, 0 in the mind, then there is no need of forming the table. Everything will be clear in your mind. So just remember one thing, you should write like this. Right now, if you want to find out the parity, so for the parity, if I'm writing P1, P2 and P3, and how we'll form the P1? P1 is nothing, it is just a what? D1 XOR D2. So just form the just do the XORing between D1 and D2. So if you will perform the XORing between D1 and D2, the answer will be what? 0 XOR 0, sir, 0. 0 XOR 0, 0. 0 XOR 1, 1. 0 XOR 1, 1. 1 XOR 0, 1. If there is the different, the answer will be 1. If the same, the answer will be 0. So 1, 0, 0. 1, 1, 1. 0. And it is 1. 1, 1, 0. I'm writing like this, right? So if there will be the difference, writing 1. And if the same, then the writing 0. Now for the P2, P2 is nothing, it is just a D2 XOR D3. So just perform XORing between these. Same, write the answer 0. Different, write the answer 1. So for same, writing 0. For same, different, writing 1. Different, 1. Same, 0. Same, 0. Different, 1. Different, 1. Same, 0. Right? Now what happened to the D3? If you want to form P3, last parity bit, then it is D1 XOR D3. So just perform between these two values. Same, answer 0, different 1. So for same, answer 0. Different, answer 1. Same, 0. Different, 1. Different, 1. Same, 0. Different, 1. Same, 0. So we are generating total what? How many codes? We are generating total 1, 2, 3, 4, 5, 6, 7 and 8 code. We are generating total 8 codes from this example, right? Now, if we want to find out the Hamming weight for this, so the Hamming weight for this is 0. Now, if you want to find out the Hamming weight, just count the number of 1 in the total code. That is the 6-bit code. So if you want to find out the number of bits or the number of ones, that is called Hamming weight. 1 2 3 3, 1 1 1 3, 1 1 1 1 4, 1 1 1 3, 1 1 1 again 1, so 4, and for this 4, for this 3. So it is called Hamming weight. And generally we'll use a word that is called D minimum. If we'll use the word that is called D minimum, the D minimum should be the D. What is D minimum? Sir, D minimum is nothing except zero code. It is called zero code. If all the data is zero, then that code is called the zero code. So except the zero code, if the minimum value of the Hamming weight, except zero code, the minimum value of the Hamming weight is called D minimum. So if you want to find out the D minimum nothing, it is just a 3. Very easy. D minimum is nothing, just a 3 for this. Right? Yes, Suraj, your answer is correct. Now if you want to find out the D minimum, the answer will be 3. Right? So how to find out the Hamming weight, you know. How to find out the code, you know. And how to find out the word D minimum, you already aware about that. Now if we'll move on the next, just I am giving you one question to you. Alright? Or before going to that give you question, just remember one thing. How to detect and correct the capability. What is the basically capability of the correction and error detection? So for the error correction, just remember one thing. For the error correction, their formula should be D minimum should be less than equal to T1 plus 1. Sir, what is D minimum? You all are aware about the D minimum. D minimum is nothing, it is just a what? Sir, all 3 data 1 1 1, then the parity P1 D1 denote D2. Sir, if all 3 data is 111, bits is 111, then P1 should be not, that is in multiplication, right? That is a different thing. The question itself is given how to find out, right? Now, so D minimum, we know how to calculate the D minimum. First remember one thing for T1, right? What is T1? T1 is the number of error or number of bits of error. Number of error bits should be detected. So if we are taking the one example for the previous one, if we are taking the previous example, just take the example. What is the value of D3? So for this code, if we want to find out how many bits or how many bits of the error we can detect, that is not correct, detect, then the answer will be, what? What about the D minimum? D minimum is 3. So just put the value of 3. 3 less than equal to T1 plus 1. So I am writing T1 should be less than, I am writing this, T1 should be not less than, not greater, actually it is a greater than or equal to. Greater than equal to, just correct this one, that is the greater than equal to. So the T1 should be less than equal to what? 2. So this code, 6,3 code, can detect the bit, can detect the error up to 2 bits. Only 2 bits error can be detected from this, right? Yes, Jagdish correct, Lavanya correct, right? Upendra correct. Now, if we'll move on the next, that is the error detection, right? So I'm writing for the above XMT, right? A code is capable of detecting T1 error if the following condition should satisfy. That is the condition. D minimum should be greater than equal to T1 plus 1. Now, how many bits or how many error can be corrected? Detection is a different thing. मान लीजिए 4 आपके पास कोड 8 बिट का है. If you will feel कि 4 बिट में एरर आ गई है, तो अगर आपने 4 बिट में एरर आ गई, इसका मतलब ये नहीं कि आपके चारों बिट को आप करेक्ट कर लोगे. आपको देखना पड़ेगा कि how many bit we can correct it, right? So to find out how many bit we can correct it, so the code is capable of correcting T2 errors if the following condition will satisfy. Or what is the following condition? D minimum should be greater than here T2 plus 1. What about the T2? T2 is the number of bits, right? Number of bits error should be corrected. So for the above code, that is called 6,3 code. If we do right, for the 6,3 code. Yes, Lavanya, correct. If you want to find out the 6,3 code, then how will find out? What is the value of D minimum? Sir, D minimum is 3. Is greater than equal to 2 T2 plus 1. So we can write 2 T2. T2 is less than equal to 2, or we can say that T2 is less than equal to what? 1. So up to 1 error can be corrected. So there will be the 2 error can be detected, but only the 1 error will be corrected, right? That is the condition, right? Now one thing more. That is important discussion. Right? What is that? I have splitted the code into 2 words, right? That is the systematic code and non-systematic code. Now I am giving you another things. What is that? There will be the 2 codes. One is called perfect code. One is called perfect code, right? Sir, what do you mean by perfect code? What is the perfect code, right? So just remember one thing for the perfect code. If any code is called perfect code, when it holds the equality sign, equality for upper bound of the Hamming, upper bound of Hamming, right? Or Hamming condition actually. What is the Hamming condition, right? Upper bound of the Hamming. Hamming condition is given like this. That is 2 raised to power n minus k. That is given 2 raised to power n minus k should be for what is, that is the condition is given like this, right? Just remember one thing. Sorry, not less than, greater than, right? I'm writing again. That is greater than equal to summation of, for I equal to 0 to n, right? Total whatever the condition is given, or t, not n, that is t, n ci. And t is nothing, it is just a up to correction, right? What is the value? Now for the equality, it should be equal. So I'm writing for n equal to 1. For this condition, I'm writing for n equal to 1. So just remember, or t equal to 1. So for t equal to 1, the condition t equal to what do you mean by t, right? So if we'll put the t equal to 1, then it will become 2 raised to power n minus k, right? For single error, right? T equal to 1 means for the single error. So for the single error correction, if you are writing, just replace the t with k, n with 1. So I'm writing just t with 1. So 2 raised to power n minus k should be greater than summation of for I equal to 0 to 1 n, or we can write nci, right? That is the condition. Now if we'll write, it will open as nc0 plus nc1. You all are aware about the value, that is n plus 1. That is n plus 1. So I'm writing for the single error correction, 2 raised to power n minus k should be greater than equal to nc0 plus nc1. We know the word value of nc0 and nc1. So the 2n minus k should be greater than n plus 1. That is the equation for what? For the single error. And if the equality holds, then that code is called what? Then that code is called what type of code? Then that is called the perfect code. Then it is called perfect code. So, and what happened in the for t equal to 2? T equal to 2 means for 2 error correction. For 2-bit error correction, that should be the condition. Just put the value of t equal to 2. So the t3 condition will generate it, nc0 plus nc1 plus nc2, right? That is the condition. Now just remember 2 codes, right? I'm just writing, there will be the 2 codes. One is the 6,3 codes, another one is the 7,4 code. I'm taking 2 codes, right? I'm taking 2 codes as an example. 6,3 codes and 7,4 code. I'm taking 2 codes. Again, I'm repeating. I'm taking 2 codes, 6,3, 7,4. Now, if you want to find out the whether this code is the perfect code or this code of the perfect code for the single bit error correction. Now, for the single error bit correction, if you find out, then for the single, what is the formula? Sir, the formula is 2 raised to power n minus k should hold the equality. And that value will be what? N plus 1. N is what? N is what? N is the total number of data length, or we can say that the code length. So I'm writing for 6,3, it is the n, it is k. So I'm writing 2 raised to power n6 k. N6 plus 1, there is no equality because it is 8, it is 7. There is no equal. So 6,3 is not a perfect code. It is not a perfect code, right? Now we can say that Bhavya Shri, actually in the class, the error correction and error detection topic is going on, right? Yes, Lavanya correct. 7,4 is a perfect code. Krishna correct. Tripathi, बहुत बढ़िया. Kishan Tripathi, बहुत ही बढ़िया, सही है आपका जवाब, right? 7,4 is called the perfect code. How we can say that it is a perfect code? Just remember one thing. For the perfect code, there will be the 7 and 4. So if you want to find out whether this code is a perfect code or not, just remember one thing. 2 raised to power n minus k should be equal to what? N plus 1 for the single error correction. So if I put the value of n equal to 7, it will be 2 raised to power 7 minus 4 should be what? The 7 plus 1. So it will be 2 raised to power 3 बराबर 7 plus 1. 7 plus 8 8 8 8 8 8 8 बराबर हो गया और बराबर हो गया तो it is a perfect code. So generally I am using what? In the error detection and correction, generally I will use the word the 7,4 as a perfect code and the 6,3 is not a perfect code, right? Why it is not perfect code? It is given in the problem, right? So I have explained it. Now I am giving you one question, just solve it. In a n, k, the single error correcting code data length is 11. Determine the minimum number of parity bits required. Determine the minimum number of parity bits are required. Just solve this question. Everybody just solve this question. Right? Only one thing is given. What? For the n, k code, single error correction. The one important word is given what? For the single error correction. So what is the formula for the single error correction? 2n minus k should be greater than what? N plus 1. We have to find out what? We have to find out the minimum number of parity bit required. Just solve this question, everybody. Smriti, sir, just for the query, क्या ये टॉपिक इसरो के लिए सब इंपॉर्टेंट है? देखो स्मृति, just remember one thing. There is no predefined syllabus for the ISRO. अगर आप इसरो के लिए आप सर्च करोगे, there is no predefined syllabus. So if there will be the no predefined syllabus, then the ISRO topic is basically the entire, right, जो भी आप communication के अंदर पढ़ते हो. Now one thing, which I have given the syllabus in front of you, that is the syllabus only we can cover or we can take from the previous 10-year analysis. हमने लास्ट 10 साल के एनालिसिस किए और आफ्टर द एनालिसिस जो हमको लगा वो चीज हमने आपको प्रोवाइड किया, राइट? इसका मतलब ये नहीं है कि इस बार उसी के अंदर से कुछ आएगा. कुछ भी आ सकता है, कहीं से भी आ सकता है. तो आप जब पढ़ रहे हो तो आपको थोड़ा सा एक चीज ध्यान रखना है कि थोड़ा सा पूरा पढ़ के जाइए, राइट? दैट इज द मोस्ट इंपॉर्टेंट, राइट? नाउ yes, Lavanya is giving the answer. 15 parity bits are required. Vishwa is giving the answer. No, Vishwa, that is wrong. Anu is giving the answer 4. Yes, Anu, correct answer. So if you want to find out what is the value is given in the problem, okay, just remember, I'm writing n minus k equal to m number of parity bit. You all are aware about n minus k. So I'm writing n minus k as a what? M. M is what? Number of parity bits. So I'm replacing 2 raised to power m should be greater than, or what about the n? So I can write m as a what? I'm writing like this. So n equal to k plus m. I'm writing n equal to k plus 1. So I'm writing at the place of n, I'm writing k plus 1. That is k plus m plus 1. M is the number of parity bits we should require, right, for this question. Yes, Rishu, correct. Yes, Rishu Sandilya, बहुत बढ़िया दोस्त. Rishu, correct answer. सर आप रैंडम वेरिएबल रैंडम प्रोसेस स्टार्ट करेंगे? बिल्कुल करेंगे दोस्त. रैंडम वेरिएबल रैंडम प्रोसेस भी स्टार्ट करना है, एफएम भी पढ़ाना है, राइट? नाउ सो इफ वी वांट टू फाइंड आउट k plus m, so what is the value of k? K value is nothing, it is just 11 is given in the problem. So 2 raised to power m should be greater than or equal to what? K is what? 11. So that is the m plus 12. So if we'll put the what? M equal to 4. So it will, minimum value of m is what? For 4. And look at the example. Yes, Nimish, correct. Nimish, hello dear. Upendranath, correct. Priti, correct. Right? Arnab, Vishwa, correct. Everybody is giving the correct answer. Yes, the answer will be 4. Now, if we'll move on the next. I'm giving you one question to you. Okay. Before going to the question, just remember one thing. The matrix representation of the block code, right? Block code, right? Now, what is the matrix representation? Then we will do the first. If we want to find out the code, so we know that code is nothing, it is just a data bit is multiplied with the G bit. And what is the G matrix? G matrix is called generator matrix. G matrix is called generator matrix. So if we want to find out the code, then just take the example. I'm just taking it as a generator matrix. And what is the nature of the generator matrix? Sir, in the generator matrix, first we should require what? Identity matrix. In the first, that there will be the identity matrix. And what is the basically the you can say dimension of the identity matrix? That is the K, or K is nothing, it is just a what? K is what? K is the number of data code, right? Or we can say that data length. So if IK, and after that there will be the what? P, I'm writing n minus K. That is the basically nature. How we can generate it? How we can generate it, right? So just remember for the generation, how we can generate it, the G matrix, that is called generator matrix. So just I'm taking the example. It is just an example. It is nothing else. It is, I'm just taking the example. It is looking like this. I'm splitting it. It is an identity matrix and it is a parity matrix, right? Yes, there will be one question. Sir, I wish to forward my message to the Gradeup team to extend the RRB JE electronics course valid till January 2018. Please, sir, for the revision process, I wish to watch it. Jyotish, I wish I could actually, I wish नहीं हो पाएगा. मैंने कल बात करी थी इससे रिगार्डिंग कि सर RRB JE वाले की चीज़ों को आप एक्सटेंड कर दीजिए. तो उन्होंने बोला कि RRB JE का एग्जाम हो चुका है तो हम उसको एक्सटेंड नहीं कर पाएंगे. तो मैंने ये जो आपने कल मुझे भी बताया था, आई हैव ऑलरेडी फॉरवर्डेड दिस थिंग एंड दैट इज सॉरी फॉर माई फ्रॉम माई साइड. बट अगेन मैं उसको एक बार चीज वापस से कन्वे करके अच्छे तरीके से बात करने की कोशिश करता हूं. इफ देयर विल दिस एनी पॉसिबिलिटी, डेफिनेटली विल डू फॉर दैट, राइट? Now in a 6,3 code, if there will be the question, just forget about that. If I'm writing the generator matrix like this, determine the all possible codes and determine the error detection and error correction capability. Just note down that question, right? In a 6,3 code, generator find, that is the G matrix, right? It is already given in the problem. Determine the parity equation. By the generator matrix, we can say that it is the identity matrix and it is a parity bit. So due to this code is basically due to the parity, that's why I'm writing it is a P1, P2 and P3. It is P1, P2, P3, right? अब कैसे होगा दोस्त P1, P2, P3? So for the P1, P2, P3, just remember, just take this as a data, right? Data की तरह इसको treat करिए and just find out how this value will be generated 1, 0 or 1. So you will get, if we do XORing with this bit and this bit, 1, 0, XOR 0, then the answer will be 1. 0 XOR 1, answer will be 0. So it is not a combination of these two things. Now if we will take D1 and D3, 1 XOR 0, 1, 0 XOR 0, 0, 0 XOR 1, 1. Yes, yes sir. This is the XORing. This will comes from the XORing of these two things. So we can write P1 is the XORing of D1 XOR D3. D1 XOR D3. Yes, yes, yes. Now if we want to find out P2, how that P2 will appear? If we'll do XORing this 1 XOR 0, 0. No, that is wrong. What happened to the first, second or third? 0 XOR 0, 0. 1 XOR 0, 1. 0 XOR 1, 1. Yes, yes, yes. So P2 is the XORing of these two things. So I'm writing D2 XOR D3. So I'm writing as a D2 XOR D3. Yes, Nimish is giving the correct answer. Now for the P3, if I'm writing. So I'm writing the for P3, D1, 0, 1 and 0, 1. 0 and 1, 1, 0, 0, 0. Yes, it is a combination of what? D1 XOR D2. It is like this, right? Yes, 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 correct. Now if you want to form what? That determine second part, determine all the possible codes. So how we will find out all the possible codes? Just remember, there will be the D1, 6,3 na. So there will be D1, D2, D3. After that, there will be the P1, P2 and P3. So if you find out what is the combination, it is 0 by 3 combination, there will be the 8 possibilities, that is 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0 and so on, right? No, I'm not writing like this, I'm just giving you the example. Now for the parity equation is nothing, it is just a D1 XOR D3. Just do the XORing of these two things. 0 XOR 0, 0, 0 XOR 1, 1, 0 XOR 0, 0, 0 XOR 1, 1, 1 XOR 0, 1 and so on. After that, you will code, generate the 8 code, C1, C2, just like C8. You will generate 8 code. And what about the Hamming weight? Hamming weight is nothing. The total number of 1 present in the code is called the Hamming weight. And what about the D minimum? D minimum is nothing. It is just like the, what about the D minimum? D minimum is nothing. It is the minimum value of Hamming weight, minimum value of Hamming weight for which minimum value of Hamming weight except all zero code is called the D minimum. So if you will find out the D minimum for this, after forming the table, you will get the answer. What about the D minimum? Just solve it. Everybody just solve this in your copy. What is D minimum for this question? Right, you will get D minimum 3. Right, for this, if you will solve it, no error can be detected. No. Now, how can you say that, Nimish? D minimum will be 3. If D minimum will be 3, then how we will find out how many error can be detected and how many error can be corrected? So, for the error detection, detection, the formula will be what? For the error detection, what is the formula? Sir, for formula 2 raised to power n minus, D minimum should be greater than equal to T1 plus 1. So D minimum 3 should be greater than T1 plus 1. So we can say that T1 should be less than 2. So up to 2 error can be detected. Up to 2 error bit can be detected. Now my question is, how many error can be corrected for this? Just give me the answer. Yes, Kishan Tripathi, दोस्त बहुत बढ़िया खेल रहे हो आप, right? खेल गए हो actually आप. So for T2, Anitha is giving the answer, Kishan is giving the answer, Vikram is giving the answer. Yes. For the error correction, you will get what? D minimum should be greater than equal to 2 T2 plus 1. So if you write D minimum 3, you will get T2 should be less than equal to 1. So up to 1 bit error can be corrected. Right? Now I am giving you one question to you, right? Just write down this question. For the 7,4 code, parity equation is given P1, P2, P3. Determine the generator matrix. First, we have to find the generator matrix. After that, determine the all possible codes. And third one, determine the error detection and correction capability. That is the homework for you, right? Homework for you. Write down. Everybody. Likh lo dost, jaldi se likh lo. Dibya 1. Yes, Dibya correct answer. Nimish, just write down this one. Everybody just write down this. Upendra. Corrected one. Correct. Vishwa correct. Just write down this question as a homework to you. सबको करना है, आज ही करना है, सबको कसम है, करके रखना, सोना है, सबको अपनी अपनी वाली की कसम है, ध्यान रखना, सॉल्व करना है इसको, कोई धोखा नहीं देगा, सोने से पहले सॉल्व करके जाना, नहीं तो कल ही ब्रेकअप हो जाएगा, बाद में मेरे को मत बोलना. राइट now decoding of the block codes, right? Decoding of the block codes, how any codes is basically detected, right? Yes, Nimish, is there a mistake in the question for this question? Yes, D1, D3, okay, yes, there will be the mistake. For this question, I am writing again, D1, D3, D4, D1, D3 and it is D4. Breakup होने से बचा लिया निमेश तुमने, right? For the P1, D1 XOR D3 XOR D4 and other one is the same. Just write down. Everyone. लिख लो दोस्त, लिख लो, डरो मत, लिख लो बस. Yes, right? 2 times I am just correcting it. It is a D4. Right now for the decoding of the block codes. Now how we can detect or we can say decode the block code. For the decoding, if I am saying that the code is transmitted through the channel and if our code is received through the channel, then how we will find out in which bit error is occurred and how that error will be corrected, right? That is given by this C, right. That is represented by the S matrix, that is called the syndrome matrix. ये syndrome matrix बताता है दोस्त. Now for the syndrome matrix, S equal to R H raised to power T. T is nothing, it is just a transpose. You know that? How to find out the transpose? For the transpose, how we'll get the transpose? actually the row is converted into the column and the column is converted into the row. That is called the transpose. You all are aware about that, right? H is called here the parity check matrix. And what is the type of the parity check matrix? The first in the what is in the generator matrix. In the generator matrix there will be the one first we have to write what, that is the identity matrix. After that there will be the parity matrix. But yes, in the generator matrix, parity check matrix, there will be what, there will be the first transpose of P, parity matrix. After that in minus k, so we can write in minus k. After that there will be the identity matrix. So the first there will be the transpose of the parity matrix, then there will be the in minus k, right? Now if we'll take the just take the example. If I'm sitting, I'm telling it is a G matrix. You all are aware what is the G matrix. G matrix is nothing, it is just a generator matrix. So if I'm taking the example at a G matrix is like this, then how we will get H matrix from G matrix? So just remember, starting three things is nothing, it is just a I. Three things is nothing, it is just a I. After that there will be the parity. So if you want to form the parity matrix, then parity matrix is what? 101. I am writing 101 110 011. It is a parity matrix. Just transpose that parity matrix. If you transpose it, you will get what? Row ko column banao, column ko row banao, aapko milega parity matrix. So if we are changing 101 disjunct, after that discount, or then discount, you will get like this. Now that is the parity matrix. Now if you want to find out what generator that is parity matrix, if you want to form, then first write what? First write transpose of the parity matrix, that is 110 011 101. That is like this. Now after that we have to write the identity matrix 100 010 001. You will get what? You will get H matrix. That is H matrix. That very easy, not that much of tough question, right? And one thing more, if the code received by the symbol, if the code received, right, that is received code R I am writing. If the R code is received, is multiplied with the H transpose, that is called syndrome matrix. And if the syndrome matrix having the zero value, if you are finding the syndrome matrix and syndrome matrix having the zero matrix, null matrix, phi matrix, right, then there is no error. नो एरर, कुछ भी एरर नहीं है दोस्त, सब कुछ सही है, सब कुछ सही है भगवान की दया से, सब कुछ सही है. बट इफ द एस मैट्रिक्स इज नॉट अ नल मैट्रिक्स, देन देयर विल बी द एरर, देन देयर विल बी एरर, देयर विल बी एरर, तो होगा एरर. अब कहां आएगा एरर, तो चेक करते हैं. जस्ट डू द वन क्वेश्चन, राइट. दिस क्वेश्चन विल एक्सप्लेन एवरीथिंग टू यू, राइट. ये क्वेश्चन आपको बहुत काम आएगा. इन अ 6,3 कोड, the generator matrix is like this. Now if the generator matrix is given, can you find out the H matrix from the generator matrix? Yes, definitely we can find out the H matrix also. How we can? Yes. Only Nimish is responding. Everybody is basically रुके हुए हैं और वो इंतजार कर रहे हैं कि कोई आएगा, सेंटा क्लॉज आएगा और आपको बताएगा कैसे होगा. कोई सेंटा क्लॉज नहीं आएगा दोस्त. सबको अपनी खुद का अपनी चीज को अगर अचीव करनी है तो मेहनत खुद की होनी चाहिए. किसी और पे डिपेंड रहने से काम नहीं चलता. Right. So if you want to find out P, what is the P matrix? That is 101 110 001. Now if you want to find out the transpose, रो को कॉलम बनाओ, कॉलम को रो बनाओ. 101 110 001 001, right? Now that is the P matrix. Now if you want to find out the parity check matrix, then first we have to write this, that is 110 011 101, and after that there will be the identity matrix 010 001. As simple as it is, right? Now the first part calculated, right? Now the second part, decode the following received code. Now if you want to decode, this is the important part. This is the important part. Everybody just listen carefully, right? ये सबसे ज़्यादा जरूरी है. सबसे ज़्यादा जरूरी यहाँ समझना है. Now, if R code is transmitted, so we have to find out the syndrome matrix. Syndrome matrix, nothing. It is a R into H transpose. So if you are finding it, R received code 1011110. And what about H? एच मैट्रिक्स, जस्ट ट्रांसपोज करना है इसको। तो मैं लिख रहा हूं 1 1 0 1 0 0, फिर इसको पलट दो दोस्त, 0 1 1 0 1 0 1 0 1 0 0 1, राइट। ट्रांसपोज के बाद क्या करना है, ट्रांसपोज के बाद बता रहा हूं दोस्त क्या करना है। ओके, यहां पे ट्रांसपोज करने के बाद इसको उठा के सीधा रख दो और उसके आगे आइडेंटिटी मैट्रिक्स बना दो, 1 1 1 आइडेंटिटी मैट्रिक्स, सिंपल। विक्रम, आर यू गेटिंग द पॉइंट? सर व्हाट डज n, k रिप्रेजेंट? सर ओह, n represent the total code length. So if the 6, so total code length is 6. Out of 6, there will be the only 3 data code that is represented by this. Right? Now, yes, Nimish, correct answer. For the first part, there is no error. No error. Yes. Now, if you want to find out for this central matrix, 1.1, 1, 0.1, 0, 1.0, 0, 1.1, 1. अबे हो जा, अब कितने बच गए? 2, 0 and 0. And it is not a normal addition. It is a what? It is a modulo 2 addition. So if it is a modulo 2 addition, जो 2 बार 1 आ गया, 2 बार 1 हो गया तो आउटपुट क्या आएगा? सर आउटपुट कुछ नहीं, 0 आएगा। क्यों? Because it is a modulo 2 addition. So if you are performing the modulo 2 addition, the 1 XORing 1, the answer will be 0. Now for the second one, इसका इसके साथ, इसका इसके साथ, इसका इसके साथ, सबका सबके साथ, आंसर फिर से मिलेगा 0. Or if you solve this into this, plus 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 this into this, you'll again, and that addition is nothing. It is just a modulo 2 addition. So answer will be 0. और आ गया क्या? सर सिंड्रोम मैट्रिक्स, और सिंड्रोम मैट्रिक्स की वैल्यू क्या आई? सर सिंड्रोम मैट्रिक्स की वैल्यू 0 आई, और सिंड्रोम मैट्रिक्स की वैल्यू 0 आ गई तो एरर होगी क्या? बताओ, जल्दी से बताओ, एरर आएगी क्या? अरे बोल दो, देयर विल द एरर और नो? देयर विल द एरर प्रेजेंट और नॉट? जस्ट गिव मी द आंसर फॉर दिस, एवरीबॉडी just respond it. Yes, that is 0, so no error will present. No error will present. So no error will present. जो कोड भेजा गया था ये बिल्कुल सही है, यही भेजा गया था और यही एग्जैक्टली रिसीव हुआ है. There will no error present in the system. Second one, अगर मैं बोलता हूं 0 0 1 0 1 आए, देखो एक बार समझो समझो समझो, ध्यान से समझो, ध्यान से समझो, राइट. नाउ अगर मैं सेकंड टाइम बोलता हूं, सेकंड कोड क्या दोस्त? जल्दी से बताओ, जल्दी से बताओ, सेकंड कोड है क्या? अगर मैं सेकंड कोड की बात करता हूं, दैट इज नथिंग, इट इज जस्ट 0 0, 3 बार 0 1 0 1, 3 बार 0 फिर 5 1 0 1, राइट. नाउ इफ यू वांट टू फाइंड आउट द सिंड्रोम मैट्रिक्स देन जस्ट मल्टीप्लाई 0.0 0 0.1 0, 3 0 तो सीधा 0 ही आएगा. उसके बाद ये चौथी बार में क्या है? 1, चौथे बार में इधर भी क्या है? 1, सो इट विल बी 1. पांचवें 0 0 0, सो 0 1 0, आंसर विल बी 1, सो इट विल बी 1. नाउ फॉर द नेक्स्ट 0 0 0 0, 3 तो 0 लिख दो खटाक से. उसके बाद चौथे बार में इधर 0 इधर 0 इधर 0, सब 0, डायरेक्ट लिख रहा हूं 0. एंड द फिफ्थ वन, दिस दैट, जो भी है करना है करो, आंसर आएगा 1. So the syndrome matrix is not 0. Syndrome matrix 0 नहीं आया दोस्त. That is not 1 0 0. That is a 1 0 1. I think that is a 1 0 1. Right, Upendra? Right. So yes, it is not equal to 0. So yes, there will be the error. Now the question is, in which bit or what bit the error will present? Question ये है कि error है कहां पर? अगर error को पता लगाना है तो what is the 1 0 1? Now just look at the transpose of the H matrix. It is the transpose of the H matrix. It is the transpose of the H matrix. Now look at that is the 1 0 1. What is the 1 0 1? So this position is the 1 0 1, and it is the first row matched with this data. It is 1 0 1 syndrome matrix और first row इसका 1 0 1 है. So we can say that directly what? There will be the error in the first position. So for the second code, there will be the error in the first position. So इस पोजीशन में दोस्त एरर आई है, पहले से बता दिया इसने किस कहां एरर आई है. एरर सर फर्स्ट पोजीशन में आई. अगर फर्स्ट पोजीशन में 0 आना ही गलत है, 0 आना ही गलत है, तो आना क्या चाहिए था? सर 1 आना चाहिए था, तब गलती नहीं होती. तो 1 नहीं आना चाहिए, तो करेक्ट कोड है क्या? करेक्ट कोड है 1 0 0 1 0 1. ये है करेक्ट कोड. ये है करेक्ट कोड। मान लीजिए सिंड्रोम मैट्रिक्स की वैल्यू आ जाती 011, मान लीजिए कि आ जाती क्या 011। सो मैच करिए 011 का, ये रहा। और ये कौन सा कॉलम है, कौन सा रो है, फर्स्ट, सेकेंड एंड थर्ड। 011 इज द थर्ड रो, सो 011 इज द थर्ड रो। इट मीन्स व्हाट सर, देयर विल बी द एरर इन द थर्ड पोजीशन और थर्ड बिट। सो 1 2 3 थर्ड बिट में एरर होता और इस 0 को मुझे 1 करना पड़ता फॉर द करेक्ट वन। सो एवरीबडी, आर यू गेटिंग द पॉइंट, राइट? सो जस्ट सॉल्व दिस वन एंड दिस वन ऑल्सो इन द वर्क। और ये भी आप लोगों को कसम है अपने अपने वाली की, और जो वाली है उनको वाले की सॉल्व करना है। जस्ट सॉल्व दिस वन, दीज टू क्वेश्चन एज ए होमवर्क। और सोने से पहले सॉल्व करके ही सोना है। और इसी के साथ एक और क्वेश्चन, ये क्वेश्चन भी होमवर्क। जब तक सॉल्व नहीं करोगे तब तक सोना नहीं है। और कसम तो दे ही रखा है, ब्रेकअप हो जाए मेरी रिस्पॉन्सिबिलिटी नहीं है, अपना खुद का ध्यान रखना, राइट? जस्ट टेक द होमवर्क फॉर दिस क्वेश्चन, राइट? And yes, I know there will be the requirement of the random variable and random process. So definitely we'll solve that question related to random variable, random process, and few concept related to that random variable and random process. We'll discuss this. And yes, the most important, that is the FM part, frequency modulation, phase modulation. How to find out the frequency deviation and the phase deviation in the equation for FM and PM. We'll discuss definitely in the YouTube session, right? So that is the, yes, that is the green card. For the 12-month subscription, that the charges is $499. And for the 1-month subscription, that is the $299. And for the buying this, you can access all type of mock test which is provided by the Gradeup. That is around more than 100. And 5th of January, we are going to analyze the ESC live paper, because 5th of January is the date. Just remind for you, 5th January is the basically the date. वो date है जिस पर ESC का पेपर होगा। और we are analyzing the solution for the ESC on the night of the 5th of January. हम उसी दिन उसको सॉल्यूशन करेंगे, राइट? एंड डेफिनेटली थोड़ा सा मेहनत करिए, डेफिनेटली विल क्रैक इट। हमेशा एक चीज देखो दोस्तों, पढ़ाना उड़ाना सब कुछ सेकेंडरी है, राइट? क्योंकि हर चीज किताब में लिखी हुई है, एवरीथिंग इज मेंशन इन द बुक, सो देयर इज नो रिक्वायरमेंट ऑफ द टीचर्स, राइट? सबसे खास बात होती क्या चीज है, आप हमेशा जिंदगी में, अभी मैं बहुत से लोगों को ये देखता हूं, दे आर एनालाइजिंग, दे आर सर्चिंग हाउ टू स्टे मोटिवेटेड, कैसे मोटिवेटेड रहें। जिंदगी में हमेशा ध्यान रखना, कोई आपको मोटिवेट नहीं करेगा। अगर मोटिवेशन रखना है तो अपने ख्वाब, अपने ड्रीम्स का मोटिवेशन रखिए, अपने पेरेंट्स का मोटिवेशन रखिए, राइट? कि पेरेंट्स के बारे में सोचिए, क्योंकि जो आप प्रिपरेशन कर रहे हो, दैट इज नॉट ए प्रिपरेशन रिलेटेड टू ओनली यू, दैट इज योर पेरेंट्स ड्रीम ऑल्सो। इफ यू विल गेट सेलेक्टेड इन द इसरो और मार्क इन एनी एग्जामिनेशन सेंटर, देन द पेरेंट्स विल बी हैप्पी मोर देन यू। वो ज्यादा, आपसे ज्यादा खुशी होंगे। तो जब भी कभी कुछ करने की कोशिश करते हैं तो सबसे पहले खाली अपने बारे में मत सोचो, पेरेंट्स के बारे में सोचो। और जब पेरेंट्स के बारे में सोचते हैं ना, तो हमेशा एक चीज ध्यान रखना, कभी डिमोटिवेशन आ ही नहीं सकता, राइट? डिमोटिवेशन कभी आ ही नहीं सकता। और जिंदगी में हर चीज ध्यान रखना, जो चीज आप चाहते हो वो चीज आपके कदमों में होगा, पर उसके लिए थोड़ा सा ध्यान रखना चाहिए, राइट? थोड़ी सी एनर्जी होनी चाहिए, एकदम तगड़े तरीके से। और हमेशा याद रखना, इसरो सोचा है तो साइंटिस्ट बन के दिखाना है, इन एनी कंडीशन, राइट? दिन रात एक कर दो, क्योंकि कुछ ज्यादा दिन नहीं है। 12 जनवरी है, 12th of Jan डेट है, राइट? 12 जनवरी डेट है, और 12 जनवरी को सेव करके रखिए। सिर्फ कितने दिन बचे हुए? 10 दिन, ये 10 भी नहीं, 5 दिन ये, और 12, 17 दिन। और ये 17 दिन आपके 50 साल को डिसाइड करने वाला है कि ये 50 साल आप जिंदगी में कैसे रहने वाले हो, इसको डिसाइड करना है, राइट? सो जस्ट रिमेंबर वन थिंग, डू योर बेस्ट। आपके हाथ में क्या है? मेहनत करना, अपना मेहनत करते रहिए, ऊपर वाले के हाथ में फल देना। एक चीज हमेशा ध्यान रखना, राइट? 2 लाइनें अर्ज कर देता हूं, कोशिश कर हल निकलेगा, कोशिश कर हल निकलेगा, आज नहीं तो कल निकलेगा, राइट? कोशिश कर हल निकलेगा, आज नहीं तो कल निकलेगा। अरे अर्जुन सा तीर साध तो सही, फिर देख मरुस्थल से भी जल निकलेगा, राइट? टिल दैट, थैंक यू वेरी मच, ऑल द वेरी बेस्ट। राडार भी हम करेंगे दोस्त, बहुत जल्दी राडार का भी मैं क्लास लेने वाला हूं।